In this tutorial video, I will introduce SPICA, a computer software for stereographic projection for interactive crystallographic analysis. This is one of the main components in the Landyne software suite. You may download the software suite from the website on the screen. Here is the Landyne launcher icon. Click this icon to start SPICA 3. Let me briefly introduce the function on the menu first. First, let's check File. The first one, New, is for you to prepare new structure file. You may load two structure files in the program, the phase 1 and phase 2, and you can save the display as JPEG or a TIFF file. Exit, leave the program. In stereogram, the first one is pole range setting. I will decide the maximum of HKL or UVW. I will decide how dense of the poles on the stereogram. Pole list editor will allow you to add new poles in the stereogram or remove the existing poles. Wolf-Knight grid and orientation and stereogram orientation will allow you to change the number of the grid and set the orientation of them. In microscope, two parameters you can change: the high tension, therefore the wavelength, or the TM holder, double tilt or rotation. These two parameters are not for the generate of the stereogram, but for other applications. We'll explain this later. In Tool, we provide a different kind of calculations. For example, angle between zone axis, angle between the plane, normal, refraction, HKL list, the convert of Miller-Bravais and Bravais indices for hexagonal system, and also calculate the normal of a crystal plane. In preference, you have the choose of region of interest and set up the TIFF file resolution. You can choose the Wolf-Knight color and the pole colors for phase 1 and phase 2, and also you can set up the font for the label for the poles. In table, we have a periodic table of the element. And we also have the table for space group. In help, we have the current drive and serial number. Copy this number to us, or just take a snapshot of the dialog window sent to us so we can prepare the license file for you. Landyne software suite is distributed with a collection of structure files, so you can use the SPICA 3 immediately. For calculation of stereogram only, the lattice parameter is enough in the input file. The software is also calculate a diffraction list for which the information about space group and atom coordinates are needed. In addition, the structure file can also use it in all software components in Landyne software suite. We will use two default crystal lattice to generate stereograms. To generate the stereograms, first select zone axis and specify the zone axis, or select the refractions and specify the central point of the refractions, and after that just click stereogram. You have the either zone axis stereogram or refractions stereogram here. The two default file names is listed here. Phase 1 is from iron platinum L10 phase, and the second phase is magnesium oxide FCC structure. And you can generate the stereograms from two phases separately, but you can show all the results in the same wolf knife. There is an option to click the mouse right button, and you have all the options to show. Let me read out for you. You can show the central cross, you can show the wolf knife, and you can show the file name of the first phase or second phase. You can show the projection pole of the first phase or second phase, the labels of the first phase or second phase. Later we'll show the trace line of phase 1 or phase 2, and also the Kikuchi map from phase 1 or phase 2. Or later TM, the angle of the TM, and the limited of the holder. You can rotate it too. You are allowed to modify your lattice parameter here to see how the lattice parameter change affected the stereogram. It's better not to create a new file here. It will sometimes confuse you. Just use this field as a slightly modify and see how the stereogram changes. Now let's test some variations. We created the first phase UVW here as 001, and now we can change it to, and you can notice the central point is 001 here. If we change here to 1, 1, 1 and redo the stereogram, we'll see the whole pattern change, and the central point now is 1, 1, 1. The relation is the same because it's the same stereogram, but the view direction are changed. And for the refractions, we did 001, and let's test for the 010. And you can see before we change is the center point is 001 HKL here, and we do stereogram, and now the center point is 011. And we can control how dense the pole point appeared here. Let's go back to the UVW 111 direction. This go to stereogram pole range setting. And for the phase 1, the maximum of UVW is 333, and the HKL is also 333, or for the maximum G value is 1. And you can select it for applied extinction rule or not. Let's change this one to 111. So the maximum will be U and minus 1, 0, positive 1, and same as with V and W. And let's go to close. Let's do this. See, only very few viewpoint, pole point is here. Let's go back. And you have a default here. Close. Redo it again. The same thing will happen to the refraction. We can control the density of the poles by use the pole range setting. But there are chances that we want to add an individual pole or remove individual pole here without effect to the others. Then we have to use the pole list editor. Let's first set pole range to close stereochrome. And we can open the pole list. And this is the original one. We reload. So the maximum here number is 2 or minus 2. We want to add 1, 3, 1 pole. We want to see this one only. So we insert, update, and you can see the new pole 131 here without effect to the others. And you can check the list here. The new list pole is here. If we want to remove 1 to 1, you can choose one-to-one here. Select it, remove, update. One-to-one pole is disappeared. By this way, if you combine with the pole range setting and editor, you can want any pole appear in your stereogram. Now I show you how to change the grid setting and rotation of the WorldNet. Go to stereogram. Now is set as 10 degrees. we want to decrease. This is 5 degrees. Birth network. If you increase to, this is for 15. And you can change the birth network orientation back to 0. You can also rotate the stereogram of phase 1 or phase 2. And this stereogram is for phase 1. And hold here. You keep the central one here and the whole stereogram is changed. You can use the arrow key precisely to adjust orientation of the stereogram. Let's reset it back to 0. If you want to just show one here, the region here, you can just use the mouse left button, click and slide in and out. Outside bar also can slide, help you. Focus. In this way, you can use the performance font to get a big number here. If the index label are very near to each other, they may overlap. You can choose of the tilt label. They try to avoid overlap them without tilt here. Because that you can choose the center by put it in different number here, same as HKL. There are a chance that you want to move here to the center, and you click on that, hold the control key, and you see a cross there, and you hit the mouse button, left button, and so you have the center move. The center move here. Then you can enlarge it, and you can see the central point is here. You can make a small adjustment, control key, and I want the 323 in the center of the screen, and I hit it, enlarge it, enlarge it. And after that, 313 again, 312, control button. So you can always move this one into, and if I expand it, so you can see this one in the center of the screen. And now I show you the region of interest and the performance. Let's put a smaller 800. And you can see a blue square here with the 312 in the center. Now only inside this blue square will be saved as the image with the resolution. SPICA program allow you to load two-phase in the program. This two-phase can be the same or different. By the combination, you can do a lot of things. For example, you can use one of them to show the trace line and the other one to show the stereograms, and superpose this trace line with your stereogram. One, you can show the Kikuchi map, and the other one to show the Kikuchi map index. If two-phase have a fixed orientation, you can load this two-phase in, and the composite stereogram will show the whole orientation relation between this two-phase. Now let me show you how to making the trace line. Show trace line phase 1 checked and calculate here, and immediately got the trace line. We can remove the wolf net. So now you can see with the trace line you show, and we have an additional spot come out. So now we get the Kikuchi map, and we're going to remove the wolf net. And for the second phase, we're going to select the UVW, because each of the knots will be the zone axis. For second phase, let's do this. For zone axis will show the same thing. To make them reduce to CF with feet. This is for the second phase. Sorry. Second phase here. And this is second phase for the zone axis. Same direction. And now you can see that if I expand the map, whole map, each of the main part components will show index on that. One important application of SPICA is for a two-phase orientation relationship. Example in the paper of SPICA in Journal Applied Crystallography 2016. The region of interest. Click here. We can select this area and save the TIFF format to find angles for each zone axis in the electron diffraction experiments. The situation is you already know the crystal lattice of the sample, and you know the zone axis you observed on the screen, and you already indexed that pattern. You want to know how to tilt the sample holder to get next zone axis electron diffraction patterns. SPEC will provide the tilt angle for all the zone axes you can reach. It's very helpful in the electron diffraction experiment, especially when you're working on a very small grain size of sample. The example is cobalt iron, chromium, germanium tetragonal phase. This example is already described in the paper in the Journal Applied Crystallography 2016 we mentioned before. In this case, this is the stereogram. And let me zoom in a little bit, change the font. And now we have 001 in the center. The situation. We know the current zone axis is 001, and the tilting angle for this zone axis on the goniometer is 16.1, and the beta tilt is 0. For the double tilt, this rotation is for rotation holder. And for the double tilt holders, we know the spot for 010 is away from horizontal, minus 14.9 degrees, and this is the condition we put in. Next, we put in new zone axis. Here, the stereogram changes, and we can put into remove roof net and show the angle of the holder, and also show the limit of the holder. The limit of the holder is defined in the microscope, TM holder, and I put 33 here, 33 here, means for alpha tilt, max minimum is plus 33 and minus 33. Same for beta tilt. This is in this area, all the angle you can reach, all the zone axis you can reach. SPICA provides several tools for very practical use in the calculation. They are all listed here, and I already have them, click them, have them out, listed here. It's the angle between the UVW, the angle between the HKL, converting from Miller-Bravais to Bravais indices for the hexagonal systems, to convert normal to a crystal plane from HKL in the Dirac space. This is refraction list, and you can save this to a file. Thank you for watching. Please check our other videos about Landyne software suite for electron diffraction simulation and crystallographic analysis.